Alright friends, welcome back. In this video I'd like to go ahead and take a second look at section 2.1 of your textbook, and in this video I would like to go ahead and take a look at a couple of equations of lines problems and yeah, just go ahead and get into that, right? So as far as equation of a line is concerned, there are a couple of different forms that you would see an equation of a line written. Of course, there's y equals mx plus b. That's our slope-intercept form. Gives us everything we need to know about what the actual line looks like as far as its graph. But there's also some other forms here. So there's what you call your standard form of the equation of a line. The reason it's called standard form is because that's the industry standard way of writing a linear equation, so that even though mathematicians across the world speak all these different languages, we can have this one standard way of writing the equation down that everybody understands, right? And there's also point slope form. So given a point and the slope of the line, you can go ahead and use this formula to find the entire equation of a line. So if I give you examples that look like this, find the equation of the line described, like in number 15, I'm going to go ahead and use that point slope formula to go ahead and get the entire equation of the line. So you notice that I gave you the slope that is going to be -2, so I'm just going to plug that in for m. X and y I keep as my general variables here, and then x1 and y1, these are of course the coordinates of a point. And so when I plug these in, I'm just going to say x minus 3 and y plus 4, because that would be y minus -4, and that would change to a plus. Next step here would be to go ahead and distribute that -2 in on the right hand side, so -2x plus 6, and then of course subtract 4 from both sides, and we would be getting -2x minus, not minus, plus 2. There we go. And so this would be the equation of the line. Y is equal to -2x plus 2. That has a slope of -2 and also passes through the point 3, -4. 16 I've already done for us here because they did tell us that the slope is undefined here. And one of the things that that automatically means is that this is going to be a VUX, or a vertical line, okay? So you'll notice that I've gone ahead and drew the picture there of my my vertical line plotted, and because it has to pass through the point -2, -1, then that's going to mean it's going to have to be a vertical line that passes through that point right there, and the x-coordinate where that vertical line passes through the x-axis is going to be at -2, and so this would be the equation of that vertical line right here, x is equal to -2. So just be on the lookout for whenever it says the slope is undefined. Of course, that's going to mean you have a VUX. Another situation I could throw your way is when I go ahead and give you 2 points of the line, and you have to go through and find the entire equation. It would be in these examples that you want to go ahead and bust out your slope formula first to calculate what your slope is, and then since you'll have a slope at that point, we could just use that slope in conjunction with one of the 2 points that you were originally given in your point slope form to go ahead and figure out the entire equation of the line here. So really quickly, let's go ahead and calculate the slope. So y2 minus y1, that'll be -4 minus -1, or in other words, plus 1, over 5 minus 1. Remember that you can subtract those in any order, really, as long as you keep the order the same in the top and the bottom. So this is going to be -3 over 4 for your slope. And so that is what I'm going to go ahead and plug down here in for m. And so now when we go ahead and reach for a point to plug in, you can go ahead and stick with x1 and y1 as I've labeled it up there, but truthfully you could pick either one of the 2 points that you were given. Doesn't necessarily matter which one. So I'm going to go and pick the one that is going to make the life easier in general, which is going to be the point with coordinates that maybe don't have any negatives in them, or maybe have smaller values to make the math a little bit easier to do mentally. But here I'm going to go ahead and stick with the 1, -1 coordinate point. So x minus +1 and y minus -1, of course, that would change to +1 there. And then, of course, when we distribute a property and bring that 1 over, we're going to have y plus 1 is equal to -3/4 x plus 3/4. And then when we add, minus your 1 from both sides, you're going to get y is equal to -3/4 x. And then, let's see, it looks like my pen is not wanting to sync with my tablet here. So is this going to work? Okay, there we go. Sorry for the pause. Yeah, so when we subtract 1 from both sides here, that is going to be -3/4 x, and then minus 1/4. And that will complete the problem. Okay, so this is the equation of the line that passes through those 2 points that we were given. So again, you're going to have to calculate your slope first and then use your point slope formula. All right, so here in the next example, same thing. I'm just going to go ahead and do the subtraction of my y's on the top, subtraction of the x's on the bottom in the same order. So this is going to be 0 over -3. And 0 divided by -3, of course, is 0. So you can see down here, whenever you move on to this step, since you're plugging in 0 for your m, it truthfully doesn't even matter what your x and y coordinate is here. Well, it matters what your which point you use here, right? So if I plug in the coordinates for 2, 0, so x minus 2 and y minus 0 here, you'll notice that on the right-hand side, this whole thing just turns into 0, and then on the left-hand side, y minus 0 just turns into y. And so this would be your equation right here. That would be a HOI, or a horizontal line passing through those 2 points, y is equal to 0. Next example here, again, same thing. We're just going to do the subtraction of your y coordinates on the top. So that would be y minus -2, or in other words, y plus, or 1 plus 2. And then 5 minus 5 on the bottom. You can see here that this is just simply going to be 0 over 3. And this is going to be undefined. Okay? So your slope turns out to be undefined. And of course, that means that we are going to be dealing with a vertical line in this problem. And so because these 2 points pass through an x-coordinate of 5, the vertical line would just be a vux, or in other words, x is equal to 5. For the next example here, you'll notice that it is giving you a little bit different information. So we give you a point to pass through, but then we also say they have to be parallel to the line that I'm giving you the equation for here. So some work that I've already done before we started the video here, I've gone ahead and solved this for y, because what we need is we need the slope. And the slope here happens to be a -3/4. If I have to be parallel to this line, then that means when I move on to my point slope formula, I'm going to have to use the same slope as what I was given from before. So I'm going to use that slope, -3/4, and then when I go ahead and plug in the coordinates of my point, again, I'm just going to go ahead and plug it in as y minus the y coordinate, and then x minus the x coordinate. Here that would be x minus -2, so that would change to x plus 2. And then using the usual steps, distributive property there on the right-hand side, so that's going to be -3/4 x minus 3 over 2. That is equal to, of course, y minus 3. And then when you add 3 to both sides, we are going to be getting the following. So y is equal to -3/4 x, and then that would be, I believe, plus 3/2 if I am not mistaken, which I don't think I am. Very good. Okay. Again, you could be using the calculator to go ahead and do those operations with fractions in the calculator to just get those answers there, but just for the sake of speed, just doing some mental math here, okay? So similar problem here in number 21, except now whenever we take our equation and solve for y, we get this slope, 1/2, and we also want to be perpendicular. So remember that when you are perpendicular, your slopes have to be opposite reciprocals of each other. So if my first slope is a positive 1/2, then I'm going to have -2 over 1 as the opposite reciprocal of that, and of course it's going to make -2 for the slope that I need for my perpendicular line. So when I move on to my point slope form, I'm going to go ahead and plug in -2, and then I'm going to plug in the coordinates of my point, so that is really easily done. So y minus the y coordinate, and then x minus the x coordinate. Again, keeping in mind, anytime you have minus a negative, that is going to change to a plus in your equation here. So I'm just going to go ahead and blaze through the steps here, and you guys can see that we get a really easy result. Y is equal to -2x plus 1. That would be the one that is perpendicular to the given line and also passes through the given point. Another example of that here, so again, anytime I'm giving you an equation, it's oftentimes very important to make sure that you solve it for y so that your equation looks like mx plus b, so you could easily pick out what that slope is. And of course, because I want to be parallel, I'm going to use the same slope as this line that I was given, so I'm not going to find the opposite reciprocal because that would be perpendicular. And I'm just going to go and plug in the coordinates of my point here and then solve. So it looks like both coordinates are negative, so that's going to mean that I'm going to have x plus and y plus, because I would be subtracting off a negative, and then just plugging in the coordinates there and then continuing to solve. Distributive property on the right-hand side, so 4/3 x plus 8 over 3 is equal to y plus 4, and then bring your 4 over, so subtract 4 from both sides, and we will get the following. So we are going to have, I believe, 4/3 x plus 4/3. Okay, and again, you guys can be doing those operations in the calculator here. So just to kind of demonstrate here real quick, again, to type in a fraction, it goes alpha y equals, enter. Oop, I typed in the wrong one. Alpha y equals, enter. There we go. That's a fraction. And then we do 8 over 3. And then we had to go ahead and simply subtract 4 from both sides. So I'm just going to go ahead and subtract 4. And in order to preserve this as a fraction, I would simply go ahead and do the math button, which is right below alpha, and then select that first option, arrow frac, and then press enter, and it'll tell me the result there. Okay, so we're going to have -4/3, which actually is a mistake that I need to go ahead and correct here. Instead of plus 4/3, that should be a -4/3. There we go. Okay, so if you want the calculator to preserve the fraction for you, you're going to have to go math fraction enter in the TI-84. So in this last example here, we're going to go ahead and see that what we are given is the x-intercept and the y-intercept. And so, of course, these correspond to where my line is going to be crossing the x and the y-axis respectively here. So if I go ahead and draw a quick picture of that, you don't have to draw the picture here if you don't want, but just to kind of draw the picture here, it would cross there at 3, and then up here at 7 on the y-axis. Your line would look a little something like that. But what we're going to have to do is come up with the equation of that blue line instead of just going ahead and making a sketch. And so, again, we're going to follow the same exact conventions here. If we have these intercepts, and it's going to correspond to these coordinate points, 3, 0, and 0, 7. And so that's playing the role of my x1, y1, x2, y2. Okay, and so if I go ahead and just set up the formula here and execute, then I'm going to have the 7 over negative 3, or in other words, the negative fraction 7/3. Okay, that is what I'm going to use for my slope down here. So the negative fraction 7/3 times x minus, and truthfully, again, you could pick any point from up above that you want to work with. I'm probably going to pick the 3, 0 because it has some smaller values in it. So I'm going to say y minus 0 is equal to negative 7/3 times the quantity x minus 3, and then distributive property on the right-hand side. So we're going to have negative 7/3 x plus 7, because that's negative 7/3 times negative 3, and then y minus 0 on the left-hand side is just simply y, and then that is our result right there. So y is equal to negative 7/3 plus, negative 7/3 x plus 7 is going to be the equation of that line. And then as another example of that, we have number 24 here, which again, we're going to do the exact same thing. If they gave us the intercepts there, we're just going to go and follow the formula to calculate slope. So that's going to be 1/2 minus 0 in the top, and then in the same order, 0 minus negative 1, it's going to be 0 plus 1 in the bottom, and this is simply just going to give you an overall slope of 1/2, because that would be 1/2 over 1, and that's just equal to 1/2. So that's what I'm going to go ahead and plug in for my m. And then again, it's up to you which point you want to work with from up above. Again, I would probably pick the one that makes your life easiest, so probably not the one with the fraction in it. I'm probably going to pick the other one, the x-intercept. So that's going to be x minus negative 1, or in other words, x plus 1, and then y minus 0. And so y minus 0 on the left-hand side is just y, distributive property with that 1/2 in on the right-hand side, and we get this final result right here, y is equal to 1/2 x plus 1/2. So a lot of different examples here where I'm giving you various pieces of information about your line that you need to find the equation for, whether I give you 2 points, or I give you a point and a slope, or I tell you that you need to be parallel and perpendicular to a given equation. We all know how to find those equations. So I hope this video has been helpful to you. If you guys have any questions whatsoever, please feel free to let me know. But that's all I have for this one. Thank you very much for your attention, and I'll speak to you in the next one.